All right. Here's how you spot a difference of two squares. Remember, you can never, ever, ever have something squared plus something squared. That pattern never, ever, never, ever, never, ever shows up. Along with having a minus trinomial at the end. You can't have a minus square at the end, a minus square. This is the only time you can have a difference of two squares. Literally ask yourself, does it look like a difference of two squares? Looks like I got a square. Looks like I got a square. Looks like it's a difference. Yeah, that's a difference of two squares. You know what this used to be? This used to be x plus 7 times x minus 7. Okay. Now in Schoology, I think I want you to pick the smaller one first. So always put the minus one first. So in Schoology, I think I did this one backwards. Okay. Or just read the directions. Okay. Something squared minus difference of two squares. This probably used to be a minus 11 and a plus 11. Know your square roots, students. Know your square roots. Something squared minus something squared. Yep, this probably used to be a b minus 2c times a b plus a 2c. Difference of two squares. If you want to make a polybox and show that it's going to be this, be my guest. Okay, make a polybox. If I'm wrong, prove me wrong. Okay, last one. Is it a difference of two squares? 16 is a square. 25 is a square. X squared is a square. Now, y to the fourth power, is that a square? Yes, it is. Because technically it's y squared times itself. So it's a y to the 4. Okay, any evened exponent, I'll repeat that. Any even exponent is a square. Any even exponent is a square. Odds, nope, doesn't work out that way. Okay, here we go. So we have something squared minus something squared. U used to be 4. U used to be an x. Minus U used to be a 5. U used to be a y squared. Times, oh, I'm running out of room here. 5, darn it. 4x plus 5y squared. I could have used one of those. I was so close. Okay. So know your squares. If you are something squared minus something squared, you are literally a difference of two squares. This never again, remember, this never ever shows up. Okay. So if you see something like this where it's like, hey, here's 36x squared plus a 25. Oh, it's something squared, something squared. Oh, nope, not factorable. Nope, not factorable at all. Can't do it. It's against the rules. Okay. That's about it. So kind of remember a few things. Remember this list. Okay. And then obviously it keeps going and keeps going. And then also, I guess, an extension of this list. It looks like I did my polybox earlier. An extension of this list. Know that any even exponent used to be a square as well. So x to the 3 times an x to the 3 would be an x to the 6. That's a square. X to the 8. Guess what that used to be? That used to be an x to the 4. Sorry, my pen's bleeding a little bit. An x to the 4, x to the 4. If you have an odd, that means one of your squares has more than the other, and that's not a square. Square is the same sides. You can't have different sides in a square, otherwise it's not a square. Okay, so here's probably a super duper crazy one. 100x to the 20th power. Woof, that's a square. You know what that used to be? That used to be 10x to the 10 times itself. So there you go. X times 10, x to the 10. Ooh, that's a square. How do I know it's a square? Look at this. Same sides. Okay, same sides. Okay, that's all I got, friends. I will leave you alone. Okay, goodbye.